Today's daily question. Question 2441. Largest positive integer that exists with its negative. Easy. Given an integer array nums that does not contain any zeros, find the largest positive integer k such that minus k also exists in the array. Return a positive integer k if there is no such integer, return minus 1. No such integer, return minus 1. Example 1. Input 3, output 3. 3 explanation. 3 is the only valid key we can find in the array. Only 3 and minus 3. Nothing else. Example 2. Input 1 and 7. Output 7. Both 1 and 7 have their corresponding negative values in the array. 7 has a larger value, so we return 7. The output is 7. Example 3. Input nums, output minus 1. There is no a single valid key, we return minus 1. No single valid key. No value negative exists in the array. Constraints. Not very large. Not equal 0. So just that's not very this is somewhat very easy. Minus 3 and 3 and 3 and minus 1, 10, 6, 7, minus 7 and 1. So 7 is the answer. And minus 10, 8, 6, 7, minus 2, minus 3. No valid. Minus 1. And this is 7. This is 3. We just use an unordered set to store every value in our store the value we visited, and when we come to a number, we check the minus, then check the negative of current number exists in the prior elements, and if it exists, then we update our return value, and we set a return value default to minus 1. Then after this, we update we insert the current value into the visited elements. So okay. It's in it. For every element n, we just check if it exists in the prior elements, then we update the return value. And after we are inserted in the n into an object, and then we return the value. So let's run. Okay, submit. It's easy. Not very fast. Maybe we should use just use set. That is still not very. We can use a vector to optimize this. So we can just because the nums size is not very large, we can use a vector and set every vector bool to check every value exists. If this can optimize, but we are use more memory. Yeah. The space of space cost time complexity when if we use under the set, we are not. This is O1, and we can use a vector. And the size the nums I, the value is minus 1000 to 1000, so we should set the size to 2001, and every element should be added by 1000. If it exists, and so now we should also we should set the exists n plus 1000. Yeah. So here we should use n. It's minus n plus 1000. This may be faster. Yeah, it's much faster than the prior, because this is a real O1, and both under the set and the set are not O1. Set is O log n, and under the set is O1, but the hash function is very slow. It's very slow to make the data wire distribution to be smooth in all data range. And the space complexity. Let's see, 2001, and the prior is ON. If we use under the set, then the space complexity is O The n is the value of the element count at most. But if we use vector, then it's 1001. Okay, so this is today's daily question. Something more about the similar question of this. This is somewhat easy, not very hard. So, and the acceptance rate is very high. So, okay. So this is today's daily question. Thanks very much.